In this video, we're going to show what it takes to 3D scan and design boat T-tops. So a customer of EMS's reached out to have 3 T-tops 3D scanned and CAD modeled because they can no longer get the T-tops from the manufacturer. So EMS went to the customer's site, 3D scanned 3 of the existing T-tops in order to design new ones from the scan data and build CAD models so they could be manufactured. What we're going to do in this video is walk you through what that process looks like, how we 3D scanned them, what we did to CAD model them, and then export CAD files for downstream manufacturing applications. For this project, we're using the Creaform HandyScan Max Elite. The great thing about this scanner is it's very versatile. It has 3 scanning volumes, short, medium, and wide. We're using the medium volume, which is about a 3-foot square scanning area, offers really good resolution and detail. We've placed targets randomly around. You can see some spherical targets and sticky targets in various places. They're about every 12 inches, 12 to 16 inches apart, randomly placed, and we can see we're scanning. Now, we're not only trying to scan the tube chassis or frame, but we're also trying to get the console, the seats, the surrounding areas. In case the customer wants design changes, we've got all that surrounding data to be able to do that. So we're not trying to get just the frame. And you just keep moving around. It's all line of sight like most scanners. You see yellow that then will turn into teal. That's telling him that he's got enough scan data based on the resolution he has set. So as he moves around, it basically lets him know he's got enough scan data in there. It's all line of sight, so it does take some moving around to get it done. That's why in this case the medium volume is pretty good, but you can kind of see what he's doing, and he just keeps moving around. We've got it set to auto shutter, so it'll automatically adjust the laser power for the surface conditions. For this boat here, it didn't have the actual top on it yet. It was still being manufactured. But you can see we've put spheres all over the console and the actual tube structure. And same thing here, we're 3D scanning. And if you look closely, you'll see a broom handle up there in the middle of the T-top. Because that's such a big open area, we put a broom handle and put some targets on that. And that just helps us as we move around to be able to track in that big open area, because the scanner always needs to see targets, and then we'll get rid of that in the actual scan data later. So in less than a day, we were able to 3D scan a 38, 32, and 30-foot boat. Next, what we're going to do is take a look at the actual 3D scan data and get into how we would actually CAD design the new T-tops. Traditionally, these structures are created using hand measurements or physical templates. Well, that approach can work. It's slow and highly dependent on the person taking the measurements, especially on complex tubular frames with multiple angles and curves. 3D scanning eliminates that guesswork and dramatically improves the accuracy and efficiency. So let's take a quick look at the 3D scan data here. And I'm going to rotate around and just let you look at it. And you can see we've got all of the tube chassis, high detail. Look at even on the console here, and we weren't really even trying to get some of this detail, but the scanner just collects so much data so quickly. Even did a pretty good job on the windshield itself, which was clear plastic. But you can see we've got pretty good coverage. Now, there will be some areas up under here on the tubes we're not going to be able to get just because of line of sight. But as you're going to see when we get into the designing of it, we really don't need that. But what you're looking at here is a highly accurate 3D model of the complete tube frame as well as the surrounding areas in case we do want to make changes. So while we're scanning, we will stop, zoom in, look at all of this, make sure we have everything before we go on to the next one. So when you're done scanning, you'll know right away that you've got all the data you need. So again, here's a look at the raw scan data. This has not been smoothed or filled in or anything done. This is literally just once we completed the 3D scanning. All right, so now we're going to get into the modeling of the console, specifically the tubes or the piping, whatever you want to call it. So the first thing we want to do is come in and import the scan data. We're going to work on this 38 footer. Now, we've already cleaned up the data a little bit and put it in a coordinate system. Pretty basic stuff. You can do that right in the careerform.os software. So I've just kind of trimmed and got rid of the scan data I really don't need. I've also put it in a coordinate system. So when I go to different views, it all looks good. And then I've also decimated it down. So what I mean by that is reduce the triangles. So originally this had about 25 million triangles, and we just don't need that much for this. It's always better to scan at a high resolution and then decimate down, because you'll preserve detail but yet make the model smaller. So what I mean by that is, you can see in these big flat areas we've got big triangles, but yet in the curved areas you can see we still have a lot of density in here. Okay, so we need those triangles to be closer together where we have curvature, but out in these big flats, and we don't care about those areas that much anyways. So it's just a much more efficient model. Okay, so we've already decimated it down. Now we want to take it one step further. So what we're going to do is I'm going to make a copy of the mesh just by selecting it and copying it. And I'm going to hide the original, and I'm going to just now trim out just some more of the data that I just don't need, right? So we're going to make the model even lighter. Plus, we're going to be running some commands that have to look through the entire data set. So this will help with that. So I'm using what they call the through command. So that'll select all the way through when I select my polygons. Or you can select what just visibly it sees, but I usually use the through version of the command. So just come in here, because that's just faster, right? Because I can get all the way through. And if I've got some triangles I want to keep, I just subtract them. And there's all these selection tools here in DesignX. We're not going to go into all of them, but you've got plenty of ways to select triangles. Pretty basic stuff. So again, we'll select, and if I grab some triangles I want to keep, which you can see I did here, we will come over in here and subtract them out. So let's start deleting some of this data. And it doesn't have to be perfect, but the more we get rid of, the better. From a data and just overall speed. And then once we're done, we'll see how big this file is compared to the original. I mean, 4 million isn't that much anymore nowadays. A few years back, maybe that used to be a ton, but we're running a pretty fast computer here. Okay, so let's get rid of all of that. So if we look at our original, we had about 5 million triangles, and our new one now is under 2. So there we go. Okay, and you could clean it up further, but that's good enough, right? And it just makes it easier to be able to see everything. All right, let's go ahead and save this. And now what we're going to do is run the tube wizard or the pipe wizard. You'll hear me say tube or pipe. It's basically it's the same thing. So what is the pipe wizard, and what is a region group? Because we're going to want to do the region group first. So actually, before we run that, let's run our region group. So we come in here. I'm going to say auto segment I've played with these settings a little bit. This seems to work good. My mesh is pretty smooth. How sensitive I want it to be. Do I want to merge similar shapes? Yes. So let me get this started, and we're on the copied mesh, and I'll explain. So what a region group does is it goes and it segments the scan data. It doesn't physically break it up. It breaks it up by color coding areas of the scan data. So it's looking for planes. It's looking for cylinders. It's looking for spheres or toroids, or just freeform or surfaces of revolution. And all it's trying to do is make working with the scan data easier and more intelligent, so that I don't have to manually go and pick data when I want to run some of these different wizards, or if I want to fit a surface through. So what it's done is it's color coded everything. And now when I highlight over, do you see how this main pipe right here is all one thing? This one here is all one pipe. Now, if it doesn't get it exact, or it gets more data, see, like this one is connected, but we know this is welded here. We'll break that up later, okay? But you can see it. This one is separate. This one looks like it broke it up correctly. Same with this one, this one. So it does a pretty good job, okay? It may not be perfect, but good enough, okay? So why do we need this? Well, we need these segments to run the tube command, the tube wizard, the pipe wizard. So let's run through one of these. Let's start with one of our main tubes, and we'll take this one here, and we're going to run pipe wizard. So now you see we're picking that region group. So it automatically knows what we're looking at. The radius, I'll let it figure out automatically. We can also key it in, but I'm going to see it here in a second. The data is pretty clean. The roughness, it's pretty smooth. I want to make it a single pipe, meaning even if it's kind of broken in spots, just make it all one pipe. So it's gonna extract and find the center of that tube, right? You see it here. It's gonna find the center and drive a bunch of points, and I can control all that. I can control how smooth it is, right? I want to follow the shape pretty good. You can see here it says it's 37. I'm working in mils. Of course, you can work in inches. I'll make it 38 because that's, there's stock sizes of this stuff, right? And I'll hit OK. So what it's done, let me turn the region group off for a minute, and you can kind of see it here, is it has driven a solid model. You can do this as a solid or a surface. I'm going to do it as a solid. Technically this pipe is hollow, but we don't care about the inside, right? You're going to take a stock tube, and the whole point of this is to CNC bend it. So there's our tube, right? It doesn't have to be hollow. Now I can also run our deviation analysis on it, and I can compare how close that tube is to nominal, right? So let's make this, what's a realistic tolerance? Let's say 1 millimeter, and let's adjust the color band. So everything in green is within 1 mil of the original tube, okay? Now, do I want to follow that tube exact? Not necessarily. I want to smooth it out a little bit. Maybe that one wasn't super smooth to begin with. If I want to adjust it, the cool thing is when it builds this command, it creates this the center line, the sketch line. So if I double click on it, I can literally come in here and pull and tug and move this line. Okay, now I'm not going to do that. Okay, but I can also, you can see how many points are on it. 162. Maybe I don't need that many. Let's go down to 75. That'll kind of help smooth it out a little bit as well. And we go back, and you can see our solid body. Okay, so I could crank the points up. Theoretically, if I really wanted to get in here and change this a little bit, I could pull it. Okay, and then when I exit out, you can see it updates it. Now I'm going to undo that. Okay, and go back. So you have a lot of versatility, even though it made the tube or the pipe. You're not stuck with it. Okay, now you can see when we get up here, it stopped about right there because it doesn't know where to go. And then we also have the end caps, the mounting plates. We got to design those. And again, same thing. The end isn't exactly where we want it, but that's all editable. You'll see that here in a minute. Okay. So next, let's go ahead and design the mounting plates, and then we'll tighten up all this data. All right, so the first thing I want to do is establish a plane. Typically, these are going to be mounted to flat areas. So I'm going to go in here, and I'm going to say create a plane, and I'm just going to pick multiple points. and just need to be somewhere kind of close to the plate itself. Okay, so by picking those 3 points, you can see we've established a plane right through there. Now you can sample more points if you want, right? We're working with the fiberglass here, so it's not going to be perfect. So if I want to sample a few more points, it's just going to average, okay? All right, so now we've built that plane. Now also, these could be stock items that you could theoretically import the CAD file for and just move into place. And there are some nice tools in here to do the alignment, but we're just going to pretend we don't have them. They're not stock, whatever. So now I'm going to go and say mesh sketch. I'm going to pick this sketch. And you can see, because again, it's not a perfect plane. It's going to wander a little. We're going to move up. We want to get right off that radius, right in kind of the meat of the sidewall there. And I'll say go ahead and create a plane. Okay, so let's hide our solid and hide our mesh. And now what I want to do is fit a circle through that. That's called a reference sketch. We're going to fit a circle through there. And just like I showed the deviation before, we could do the same thing in 2D. Okay, so we can actually look at this and see it kind of wander in and out, because you're always scanning a manufactured part. It's never going to be perfect, but we're obviously fitting a perfect circle. Now let's go ahead and throw a dimension on here. It's 133.6. I'll make this 133.6. It was 0.66 something, right? Let's make it 0.5. Okay, so you can override that, make it anything you want, like if you know exactly what the size is supposed to be. Okay, now, let me go back into that command. The next thing I want to do is I want to add the holes in here. Now, it doesn't look like, and they're not in a pattern, and part of that is because you can't screw in from behind, right? So we can't really use a bolt pattern for this, but we can use the center point, assuming they're all in the same line. So what I'm going to do here is I'm going to make another circle right from the center, and I'm just going to eyeball right where the center of that screw is, okay? And then I will use that, so I'm going to right click and make that construction geometry because I don't want to keep it. And then I'm going to pick here, and I'm going to, I'm going to find the center. Now, we could do a mesh sketch, but this will be close enough. And I'll pick the center point, and then let's just make it 7.5, okay? So I'm going to do that one there. Then I'm going to do one here, okay? And then I'm going to do one here and do one here, okay? Now, I didn't define the radius on the others because what I'm going to do is click the first one, double click the second one, the third, and the fourth, and I'm just going to click equal radius, and it'll make them all 7.5. So if I change it later, they'll all update, okay? So there's our plate, okay? And now let's give it some thickness, okay? So we're going to go and extrude it, and let's get in a kind of a view we can see it in, okay? And again, if you know what if this is a standard plate of a standard thickness, then you'll know what to do, okay? I'm going to get it. You'll see it kind of snap right to that scan data. And again, I'll say, well, let's just make it, I don't know, 10.5, okay? And we do not want to merge it yet with the other one. So I'm going to do an insert, meaning the original body we built. So let's take a look at what we have, okay? So there it is. It's got our holes in it, but now I need that radius. So I'm going to come in here and say fillet. And what's cool about Design X, if I click this little button here, it's going to look at the scan data, and it's going to average that fillet and tell me what it is. So it says 6.8. I'll make it 7. All right, so with that done, let's go ahead and look at now the top. Now this one's a little different. There is no hole in it, or holes, okay? So we're basically going to do the same thing again. We're going to create a plane. We are going to pick multiple points, and I'll sample a few along here just to try to average a plane. Once I have that plane, we are going to go to mesh sketch. We are going to move up, okay, and hide the mesh. We're going to fit our circle. And you can just type in 2 here, right? The radius. So let's just make it 63. Okay. And we don't have any holes to add, so we'll take that. Let's bring back our mesh. And now we're going to extrude this one up. Okay, and again, let's get into a true view. You can see that one's not as tall. And you can kind of see it kind of snaps. We can make this, again, if it's a known size, make it whatever it is. We'll make that 11.5. And we merged it. So this is new in the latest version of Design X. This has some nice advantages because you can kind of pick what to cut or merge to as far as bodies, but the default is merge, and that always gets me because I don't want to merge it. I want to keep it as a separate piece. Okay, we're going to add our fillet again. Same thing. We're going to click. We're going to ask it to look at it. You can see this one. We're going to make 10, and we'll take it. Okay. Now let's take a look at our tube. So same thing. It doesn't know where to end it, right? It just kind of, runs out of the region group there, and so it just kind of stops. So again, we got to figure out where we want it to go. Do we want it to go to here, up a little bit, whatever you want to do? I'm just going to assume it's going to be here for this demonstration. So we're going to add a plane. We are going to move the face. The direction is the same as the face. There are times you want to move it in a different direction, but usually I go with this. And then we are going to cut the tool, the target, and then the remaining, okay? And again, I want to keep these as separate pieces because, for manufacturing purposes, they are, okay? So let's take a look at what we have now. So let's go back to our mesh. So we have one completed tube. And the beauty again of this is I don't have to sit here and try to figure out all these bends. It does it for me, okay? And I have control of that. I can control how smooth it is, how tight it is. And if, let's say for some reason I wanted it to be different, maybe I'm going to design it a little different, I can do that too. So you have full control here. So there's our tube with the top and bottom mounting plates, and there's our mesh, okay? So that looks pretty good. Let's save our file. Okay. And now what I want to do is, theoretically, I should be able to mirror this over to the other side, right? If this is all symmetrical, I should be able to do that. Okay. I mean, it looks pretty symmetrical, although you can kind of see maybe not. But I just want to show it anyway. So let's assume it is. Or if we want to test if it is. We're going to go back to that original mesh. Okay, we're going to go into a view like this. We're going to build a plane, and the first plane we're going to make, we're just going to draw it. And what we're trying to do is just kind of get close to where the center mirror plane would be. Okay, it doesn't have to be perfect. You just want it kind of close. And now we are going to now do a mirror plane, and we are going to use this plane as a starting point, and we are going to look at this mesh and find the true mirror plane. So it's going to say, okay, in this direction, I'm going to look at data on both sides, and if this part is pretty symmetrical, it will find a true mirror plane. I mean, it will find a mirror plane no matter what, okay? So if you look, they're pretty close. So I was fairly close in my guess, okay? But they certainly are different. Okay, so that is a mirror plane, and since this part is pretty symmetrical, doesn't have to be perfect. Obviously, the steering wheel and some of these things are there, but it's smart enough to figure that all out. Okay, so I'm going to hide plane 5, and then what I always do is I rename the plane. I'm going to call it mirror, so that I don't accidentally pick the wrong one when I might be doing something. Okay, so now I'm going to turn back on the solid body, which you see here, okay, over there. And let's go back to our other mesh, okay? And we are going to mirror it over and see what it looks like, because obviously that would save us a whole lot of time. Pick this plane and hit OK. And and let's take a look at it. But obviously right away, we can see we've got some problems, okay? So you can see they don't line up, okay? So they're definitely off. Now, is that, in the marine world, sometimes things aren't perfect, or is it just not really symmetrical? I don't know. I'd have to look at it some more, but obviously it doesn't fit. Now, can I come in here and try to move it into place? Well, one thing we can do is transform the scan data. And, we could try to say, let's try to move this in, but this is all just kind of guessing, right? And you can see it kind of fits, but you can see up here it really doesn't. So even though I got it pretty good, but you look over here, I didn't. So bottom line is we're not going to be able to mirror this over, okay? It's just not the same. Not if we're trying to follow the existing design. Now, if we were trying to do it differently, then yeah. So I'm basically going to undo that and get rid of it, okay? So we're basically probably going to have to design this whole thing, and that's okay. So now let's go ahead and do a more complicated one. And to do that, let's take a look at our region group. Now you'll look here, this tube, okay, this whatever color this is, pink, fuchsia, whatever. When we get up to here, you can see it's still connected coming around here. It does end properly here. It does not end properly here. So we're going to have to come in and break that up, okay? And that's easy to do. So I go to my regions, and what I'm going to do is I'm going to use this little paintbrush tool, and I'm just going to come in here and kind of paint these regions, okay? And we're basically going to end up what we call splitting it, right? So we don't have to be super, you can see where it's kind of joined, right? We don't have to be super critical here. We just want to get it just so it breaks it. So now I come in here and say split. So you can see we've split it. It's just some of this is, it's a separate piece, but it's kind of the same color, right? Because there's only so many colors. So you can see now we have that split the way we want it. Okay. So now we're going to run the tube wizard command again. Pipe wizard. Check something here real quick. Which one are we on? I want to do it all on the same side. Okay, yep, so we're on this side. Okay, so we're going to pick that. We'll take the same defaults because they worked pretty good last time. And you can see our pipe here. Looks, and you get different views of it, right? So if you want to look at it here. So this is kind of nice. You can kind of see it in different views. But I'd say that looks pretty good. The radius, let's go 24. And let's take a look at it. Okay. So that looks pretty good. Obviously, again, the ends we're always going to have to work with. Okay. So let's work on this one here because the other one is similar to what we've already done. And I'm going to hide the region group. But obviously here, we need to work out how these two intersect, okay? So that's what we're going to work on next is how do we cut this tube off so that it mates this one properly. Okay, so like I said, let's go ahead and work on this. So let's hide the mesh for a minute, and let's bring back the down tube for the other one, okay? So let's hide for a second. We are going to now move face again because we got to get it to fully intersect this tube here. Okay, so we'll hit OK. Now, what I need to do now is cut this tube off, but kind of hold the shape. Let's hide those for a minute, right? But hold the kind of this shape here so they mate up. But when I do that, do I want to cut it exactly where they fit? Or do I want to give a little bit of space for welding or just a little bit of clearance, right? Theoretically, you don't have to. I could cut this right where it is. But I'm going to give myself a little bit of play in there, okay? So to do that, I'm going to come in here and I'm going to say offset surface. I'm going to pick this tube, and then I can go whatever I want. 1 mils, 2 mils. Let's just go 1 millimeter and hit OK. Okay. Now this is just telling me it's an unsupported feature when you do live transfer. I won't get into that, but when you get into doing things like live transfers and stuff into like SolidWorks or others. You got to be aware of some of this. Okay, so what did I end up with? Well, now I have a surface that is 1 millimeter thicker than that solid. So we just offset, probably kind of hard to see, but you can see here, the yellow is a surface, the gray is a solid body. So this is 1 millimeter thicker, okay, offset outward. And now I'm going to use that to do a cut. This is my tool. And now my target is this. And I'm going to keep that, okay? So let's hide the surface. Let's hide this. So now, look at that. I've got that perfect cut, but I've given myself, right, a gap in there, okay? Because sometimes you want that for welding. Sometimes maybe you don't, okay? You can do what you want, right? But you can see how quickly we're able to do that. And again, we've got the perfect fitting tube, okay? And let's come down here. We'll do this one again, and then we'll get to something else, okay? But you've already seen this once, but we'll do it one more time. That way we can focus on just different things, okay? So pick some points. And we're going to run that fillet. That'll remember what it was last time. Okay, there we go. So you can see in a matter of minutes, we've already built these two tubes. Okay, pretty good, right? Pretty good, pretty fast. Okay, and we know, we know we're accurate. Let's turn on our deviation map. Okay, so everything in green is within a millimeter. So pretty darn good. Okay, and again, you can make that as tight as you want. Okay, generally, I don't crank it to be super tight because sometimes these aren't they're not perfect. They don't have a nice continuous curve. So we'll make it that way. Okay, so we've got those two. Let's go ahead and build this piece out here, and then maybe we'll do like the connector to the rod holder as an example. Okay, so let's turn our region group back on. This should be, and it is, a separate piece. Let's go to our pipe wizard. Let's pick it. Again, we'll take the defaults. It's determined the radius is 24 something. We're going to even it out at 24. The shape to me looks pretty good. Not going to get too picky. Let's hide our meshes for a minute. So again, we're going to have the same issue here. Now we haven't done the other side, so we won't trim that out. Okay, but we will trim this side here. Okay, now let's zoom in here. I'm going to turn the regions off for a minute. Okay, so you can see the pipe. Pipe kind of goes where it should, and then it becomes how far. Where do we want to end it? Well, I would say it probably ends out here a little bit more. So let's come in here and move this face out just a little bit. So maybe to about right, let's say there. Okay, so that gives us our end point. And now we've got to do our, let's do our same offset again. Oh, we didn't do that end there, but we'll take care of that. So let's go to our offset. We're going to pick this guy. Do we want to go the same amount? Let's try it. Turn our surfaces back on. And let's see what we get here. So we're going to do a cut, tool, target, side we want to keep, and then hit OK. Okay. Now, you can see what we've done. Okay. So we've cut that away. Now, you could say, well, look, I'm not really going to cut that tube like that, right? So it's kind of wonky in there. You can come in here and further manipulate this because, we're being super, super precise here, right? So you could just say, look, let's bring that mesh back for a minute, right? This really needs to get cut off, okay? So there's a few ways I could do this, okay? What I'm going to probably do is just try to line it up. There's a lot of ways you could do this, but I'm just winging it here. I'm going to say draw a line from like right here to there. And, we could also fit a plane and just cut it there. I'll show you that too. Okay. And let's hide the mesh. Let's do a cut. Target. Oh, target body. Keep that side. Okay. And maybe clean that up a little bit. Okay. So, and you could even say, well, I wouldn't do it that, that's too chopped up. I wouldn't do that like that. So let's go back. Let's undo the whole thing. Okay. And let's hide the solid. Let's just create a plane, right? Maybe we're just going to keep this real simple. So let's go and pick multiple points. And I'm going to pick, because we probably want it up here. You could also build a 3D sketch in here and do it that way, okay? But if you didn't want to get it too crazy and just kind of keep it simple, we could do this, okay? So again, it's endless the way you do this, okay? So if that looks more realistic to how you would do it and weld it up, then do it that way, right? So you've got options, okay? So there's that. I'm not going to finish out this down here because, again, it's just extending and trimming. We've already done that. Let's add the rod holders, or at least one of them, okay? So they're all a little bit different, but could we do them all in one go? Maybe. So let's go to the top view, okay? And again, this gets into things being symmetric. If I look at this, this almost doesn't look evenly spaced and uh, doesn't look symmetric. So we're going to make it that way, right? Because depending on the jig or the fixture when they're building this, I mean, who knows, right? Okay. And that's the beauty of this. That's the beauty of doing things digitally, is it lets us make changes to it. So I'm going to go to the right plane and I'm going to drag a copy down. Let's see, about right. I want to get it right. Let's say right there. Okay. All right. So there's my plane. Now I'm going to come in here. I'm going to say mesh sketch. I'm going to pick this. Okay. And we didn't get scan data up on this side because that was up against the top, right? So you really can't scan, but that's okay. We don't need it, and you'll see why. Let's hide the mesh. Let's hide our solids. Let's go back to our true view. We're going to model this one here in the middle. I'm going to go pick the slot command. I'm going to window this in. Start that over. Window this in. Okay, so hold on here. So let me go back. So you can see it's horizontal and everything. It's parallel, but it's not horizontal. So if I right click and make horizontal, so look, you can see the difference, right? So I think this will fit right. And you could dimension all this, but you can see again, things are just in the real world are not perfect, right? So now we're going to make that perfectly square. And, let me go back into that sketch because what I want to do now is I want to pattern it. So let's go back to our true view. Okay, and let's flip it this way so I can see it. So let's do a linear pattern. Pick this guy. Let's just go one direction to start with. Oops. And we want, I think that's going to be 3 copies. Three copies. And I'm going to line up. Okay. So we've done that. Okay. So we're making them exactly the right length apart. We're going to repeat that command and go this way. I think my spacing, I'd have to go back and look, but I think I said 205. Yeah. Okay. So there we go. So you can see they're off a little bit, okay? So now they're all perfectly in line, okay? So let's bring back our mesh, okay? And let's extrude them out. Okay, so we're going to go this direction. We're just going to go back in a certain amount. And then same with this way, right? We've got to make them longer first, then we'll trim them out. So let's see how those line up, okay? So, you know, pretty good, but definitely now they're perfect, okay? And let's go ahead and turn on our regions, okay? And, you know, do we need the tube wizard for something as simple as this? No, not really, but we'll just run it for simplicity, right? Or here, let's do this. We can just run the solid primitive command. We're going to tell it it's a cylinder. We're going to pick this. We can extend it if we want. Okay, so you can see the scan data is a little rough on there. Let's do a preview. So you can see what that looks like. Actually, let's not extend it. Let's just go 0, and then we'll just manually move it. Okay, let's say that one looks pretty good. And this one looks, maybe it's a little bit short. So we'll come in here and we'll say move face. And again, you could go with a very specific amount for these. I'm sure there's kind of a maybe a standard, but we'll move it there. Okay. So just like the mesh, let me hide the region group for a minute. We can transform a body and pick it, and we'll say duplicate. And I believe this was 205 is what we had said. 205. You know, we can make copies of this, okay? And we'll just do that again. So, you know, this is just kind of basic CAD stuff here. 205. But again, we're going to make everything. I won't do all of them, right? And then it's just a matter of trimming these up. You know, however you want to trim them up, right? So, and each one, you're going to have to do each one because you can see it trims in a different spot, right? Okay. So let's take a look. So you can see what we've built already here in pretty short order. Okay, let's see if we have anything else that's you know, fairly complicated. So here we've got 2 different rail sizes. That's fine. That's not a biggie. We've got a short piece there. That'll be easy enough. Another down tube here. You know, another one here. But all of this is just, again, rinse and repeat, right? So how long would it take me to model this whole thing, knowing I'm pretty much going to have to do everything and mirror nothing over? You know, 3-4 hours probably. Let's call it a half a day, and we're going to have a full CAD model of this. So I'm going to go ahead and model the whole thing, but we'll just speed this up so you don't have to sit here and watch me do every little piece of it. But you can see how quickly we can go from scan data to CAD data. Now, once this is done, we can export this, you know, basically as an assembly, but keeping it as all individual pieces. Also, keep in mind when we build these tubes, you also get these 3D sketches here, and these are all the centers of those tubes. So theoretically, you could just export these if all you wanted was the center line, right? But you know, and you can also extract a new center line of the solid body. So, you know, you've got all the geometry here you need to go to CNC bending, or if you're just going to make drawings and blueprints, you could, you know, theoretically pull all the dimensions off this. But, you know, these are in 3D shape, so you know, they would be a great example of CNC bending. It would make life a lot easier because all you got to do is put in that center line, and, you know, it'll drive it and build it for you. Okay, so we're speeding this up, but I am going to slow down again when we get to some more areas that show kind of some unique geometry and how we have to do things a little bit different. But again, a lot of this is just very repetitive. As I mentioned before, you could have these plates already pre-designed and then move them into place and actually align them to the scan data. For this example, I just built each one because the holes do appear to be different in certain spots on some of these. But again, you can see a lot of this is just the same over and over to get most of this tube chassis or tube frame designed. Okay, so I want to show this area here next because it's not a tube. You can see it says torus, right? So it's kind of a flattened tube in this area. So what do you do then? Because the tube wizard is going to struggle with that because it's going to want to try to force a tube. So we're going to use the sweep wizard instead. We're going to pick this and pick that. And we'll just take the defaults and we'll see if it can figure it out. The good news about these wizards, though, if it can't figure it out, is it's not a complete loss because we still should be able to go back and manipulate the geometry. And that's what you're going to see here. It's going to take a minute. It's trying to figure out how to do it. But sometimes there's not enough scan data there, or it's just maybe the shape is too complicated, or the scan data just isn't good in that area. And it just can't figure out what the profile is supposed to look like and then what the center line is. So it's going to take its best shot at it. And if it can't build a solid body, it's going to come back and say, hey. And you can see right here, here's the profile it's trying to make. And I don't know what's on the backside there. Maybe there's a weld. Maybe there's some missing data. Let's go ahead and take it. But you can see it didn't go well, okay? But again, the good news is let's hide the mesh for a minute here. And let's turn on. There's the sketch. And then there's the center curve. So you see how I have these two things? So even though it failed to build a solid body, I can double click on this mesh. I'm just going to pick it and delete it. Let's go into a true view. And you can see what it was trying to work with there, right? So it's not that good, but the beauty is I can fit geometry through here. So I could maybe try to fit a slot through there and say, yeah, that looks pretty good. Or I could fit an ellipse. So let's just go with this slot. And, you can move and manipulate it any way you want. But I'll say, hey, that looks pretty good. Because it's almost like the rail is kind of squashed, so to speak. So there's that. And then the curve itself, just like the other curves, you can see it's a little rough in there. So let's double click that. And, we can come in and pull these points a little bit. Let's do this. Let me undo that for a minute. Let me see here. And what I'm going to do is adjust the area of influence just down to about right there. That's when I tug on this line, how much it's going to change it. Okay. And let's crank her down to about 8 points and really try to smooth it out. Okay. And let's go back and look at our mesh. So yeah, that looks maybe pretty good. Okay. So now I'll just run the manual sweep command. So we'll come in here and we'll say sweep. This is our profile. There's our curve. Let's turn back on our mesh. And now you can see what we have, okay? So even though the wizards don't always work, they leave behind the center line and the sketch that it built, because that's essentially all it's doing underneath, right? They leave those behind, okay? So now it's just a matter of building this plate and then offsetting this surface and extruding it. But I thought this was kind of a good one to show where a wizard doesn't work, but you're not left high and dry. You can still go in there and manipulate it manually. Okay, so we'll speed it up again for some of this. So again, it's just building out those plates and trimming everything up like we did before. But we are going to slow down again here in a minute where we're going to show you where two pipes don't necessarily fit well together. So again, this is just kind of repeating. For these simple straight pipes, I'm just using the standard solid primitive and making cylinders. There's no reason to use the sweep, the pipe wizard. Here you can see, again, just cutting a section, building a slot shape, and trimming it up. This one didn't line up perfect. You see here I have to kind of extend it a little bit to get it to trim because I have to intersect. Okay, so here's another interesting thing here that happens sometimes is the tubes, the drive curve, the way it, and you can kind of see it here, they don't line up. Now, part of the problem is I mirrored this over just for time, and you can see then I use this actual tube to drive it. But it actually is a good example because what I can do is I can come in here and alter that curve like we did before. So again, let's crank our points down to like 8. And let's hide the solid for a minute. And, I could pull and tug this thing over a little bit. Okay, and again, I have this influence area. So if I do that and bring the solids back, you can see what I'm starting to do here, right? So let me pull it over a little more. And now you can see it's lined up, okay? So even if things aren't perfect, there's usually a way to be able to adjust that drive curve. So even though it built the center of it, I can pull it and move it. So that's pretty handy. So now when I cut to my offset, because otherwise it's not going to cut right because they don't intersect properly, right? So that's a nice feature to be able to do that. And then we'll just grab and create this plane here, do this cut here, keep that side there, okay? So just thought I would show that because that you don't always, like we've shown before, you don't always have to follow the scan data perfectly. Okay, we'll speed it up again here. We're doing the outside rails now. Those are pretty straightforward. And in this case, I'm just moving and copying over the mounting plates because it's pretty straight, or pretty much a pattern along there, and just moving them in place and then trimming everything up here on these kind of side rails. Okay, so we'll stop it here, but you can see what we able to do. Here's our scan data. And there's our finished part. Now, again, for time, I mirrored a few of them over just to save time, so they're not perfect. But you can see how quickly we can model things using DesignX and using some of those wizards and more advanced tools. We've got this, pretty much roughed in shape-wise. So that'll just kind of wrap up what we did here. Again, here's our scan data. And here's our CAD. So now once we have this, we can export all of this as step, IGES, Parasolid, CAD, regular CAD formats, where scan data is just STL data. It is not CAD data. So whether we're going to go now create drawings and assemblies, or we're going to go to a CNC tube bender, or whatever we're going to do, we've got full-blown CAD to do that, where again the scan data is not CAD. It looks great, but you can't use it for most downstream applications. You can't really pull and create prints from it and drawings. You certainly can't drive a CNC bender or any kind of equipment with it. So or a CNC mill. Okay, so raw scan data, and now here is our solid model. And again, if we want to make changes to it, we can absolutely do it, or we can follow it exactly as is. And finally, another really cool thing we can do is we can create really nice, realistic renders of the new design and made it up to the existing console. So we took that scan data, we deleted out the old tube structure, and we've added in the new CAD file we created. Now, in this case, it's pretty much the same, but let's say you did want to make some design changes.
Now you can show this to the customer and they can actually see what the new design might look like. The other thing you can do is imitate the movement of the sun in the sky to show how it would cover. You can actually pick a time of year and a location and imitate the sun's movement. So if you want to learn more about EMS 3D's services to do 3D scanning and CAD modeling, or maybe you're interested in buying your own 3D scanner, you can give us a call at 877-845-2700 or send us an email at info@ems3d.com.